Hello. Hi. I'm Jonathan Wolff. I've been an Ethereum dev for about 10 years. I was formerly lead Ethereum dev at Streamer and Beacon Protocol, and now I'm here presenting my own project, Brevity, which is remarkably similar, or a similar solution to Wayroll that Colin just prepared. It's a very similar technology, but very different under the hood, and it has some different features, so I'll explain that. But it's basically a scripting system, sort of like shell scripting for the EVM that allows composable DeFi workflows. And the goal is to bring this to consumers, basically. Bring one-click DeFi to consumers, one-click composability. And so it's a similar motivation. So DeFi is this new democratized finance system. There are all these different ways to earn yields. But a lot of the ways are, a lot of the yield-bearing assets and protocols are inaccessible to normies who don't know how to use DeFi and these GUIs. So some actions require multiple steps. For example, creating like a Uniswap liquidity position, and some features like flash loans are just completely inaccessible to anyone who doesn't know how to use Solidity, because you have to follow a pretty complex coding pattern with a callback that's in bytes. And the question is, how can consumers easily and safely compose DeFi workflows? So this is Brevity. It has a console. It has a language that's really similar to Solidity. It's not Solidity, but it's meant to be as similar as possible to Solidity to bridge the gap. And it's a basically functional, fully expressive programming language that fits in call data. So running atomically is important. So the whole script runs in the EVM as one. It either succeeds or reverts. It does support if-then statements and conditional branching. It does support variables and sort of normal arithmetic. You can use all the arithmetic that you use in Solidity also. So it's a fully expressive language. And you can, for example, arb to exchanges and then revert if conditions are not met. If profit is less than X, then revert, for example. That's expressible in Brevity. And it's easy to add to an existing project. You can clone a Brevity interpreter or just fork the code and add it to your existing smart contract. You can also delegate call to a Brevity interpreter. That's another way to integrate it. And Brevity has a composable GUI that I'll get to later. So I'm going to run through some PowerPoint slides, then we'll get to a GUI, and we'll actually run Brevity and do some flash loans and add some liquidity to Uniswap. So the fact that it's a scripting language allows you to have a GUI with steps that compose, and users can just click on these things and add, and it will generate the code that we saw in the previous slide. So we'll get to the GUI in a minute. Colin had a slide about multi-call also. I have a slide about multi-call. Okay, it's like multi-call but better. So people ask, why is it different from multi-call? It's a fully expressive scripting language. It has variables, math, flow control, and then it has some other features like sandboxing. So it has guardrails. It supports metatransactions, and it even has metering and some gas savings in certain situations. And I'll get into all these different details, but it's a scripting language that runs in a controlled environment. And it is the world's easiest flash loan interface. If you've ever done flash loans, you're doing a callback with bytes to a smart contract. This is how you do it in Brevity. You put some directive at the beginning of the script that says that Brevity should run the whole script as a callback to a flash loan. And then you just you do the pool manager unlock, and then the directive does the unlock. You take out some coins, you do something, and you return them. And in the part that says do stuff, you can just copy and paste code, and it'll work. And we'll do a flash loan later. We'll just create some money out of nothing. So flash loans, for those of you who aren't familiar, you can take out any amount of money from Uniswap and Aave in one transaction, as long as you return it in the same transaction. But the coding pattern is quite difficult because they ensure that they call you back, and then you have to return the money to them. So. The Brevity robot, that console that I showed you, is a typical implementation. I call that the Brevity robot. So that's like a personally owned Brevity interpreter. It's a cheap contract. It supports the clone pattern. Costs like 100,000 gas to deploy, so a few cents to deploy on mainnet. And your Brevity interpreter holds your tokens, and it sort of does your bidding. You type in scripts, you press run, and then it just runs it for you. And it holds your assets, and you can remove your assets at will. You can put Brevity in different configurations. This is probably the most obvious configuration, where one person owns a robot, and then gives the robot commands, and then can take assets off at will. So in the demo that I'll show coming up, each Brevity interpreter has like token holdings, and you can just pull off the tokens from your own Brevity interpreter. Right. So under the hood, it's a simple scripting language and a general purpose interpreter smart contract. So that language that I showed is not Solidity, that's a parser. It transpiles that text that I showed at the beginning, which is the Brevity script, into instructions. The instructions are put on call data. So an important distinction between Solidity and Brevity is Brevity programs live on call data. They're not stored to code. And that's why you can have some gas savings sometimes, because writing to code is substantially more expensive than storing bytes on call data. It's at least 10 times more expensive. It's about 200 gas per word on code, and I think 4 to 16 in call data. And so Brevity can run new logic without deploying a new smart contract. That's an important feature of the language. And it doesn't replace Solidity, so I want to make clear that this is not a competitor to Solidity. I liken it more to like C programs and shell scripts. Like you write C programs to do highly numeric computations or do some unique function, and you write the shell script to do the interstitial calls between them. And Brevity handles that, so it handles full logic in between them. You can do if, reverts, you can store variables, do arithmetic on variables, and do flow control and all that. And it's, to my mind, the most general thing you can put in a callback. So if you want to put something in call data, and many things take callbacks. So for example, like bridges take callbacks, flash loans take callbacks. Why not put a Brevity script in the callback? Because it's the most fully functional thing. It's a general purpose script. And one other thing I'll say about Brevity is that it can be configured to work in a sandboxed environment. And I think this is a very important point, that you can sandbox your Brevity interpreter so that it can only make calls out to certain contracts. So for example, if you're a finance company looking to offer Brevity as a service to your customers, and you want them to be able to compose DeFi workflows, you can limit them and say that you can't send it out to unregistered protocols or unregistered addresses and so forth. So there's a hook that occurs at every time you do a call in Brevity, which is different than writing freehand Solidity. That's one risk you'd have with freehand Solidity, is that you don't have this sort of hook each time you make a call. And this is where Brevity really excels and beats Solidity. The UX, it's a really, really simple coding. So the scripts are typically very short, could be 3 or 4 lines of code. Do this, do that, revert if some conditions are not met. And this is much more easily expressible in Brevity than it is with a custom Solidity contract. In addition, your Brevity interpreter never has to move tokens outside it because it can run everything. So if you had a Solidity contract that had some limited functionality, you don't have to move the tokens in and out of that and vet the new contracts. And so writing Solidity contracts, to do new DeFi operations is not ideal. But Brevity, because it's sandboxed and very concise, is ideal for this. And it has guardrails. So the guardrails are a big part. And then the AI integration. So I've taught Claude Code to write Brevity. Claude Code writes fluent Brevity. It just read the README, and it understands it immediately, because Brevity is a fairly simple language. We'll get into the syntax maybe a little later if we have time. I'm going to do a demo, and then I'll show you some of the syntax of the language, but that's maybe getting into the weeds. But you can just tell Claude Code arb some exchanges, and I'll show you some examples of code that Claude wrote, which is pretty impressive. One got Brevity, and 2 wrote scripts that compile. I haven't made millions on it yet, but I think you need infrastructure to kind of wait for certain market conditions. But to my mind, it's the best tool to train AI to do DeFi. And one other thing about Brevity is it has potential gas savings. So as I mentioned before, when you're deploying Solidity contracts, you're writing them to the code area. It's 200 gas per word or something, and Brevity can save you money or save you gas fees because all the stuff lives in call data. So if you're only using it once, if it's a one-off script, you might as well just use Brevity, because you'll actually. I have an example on the Brevity GitHub. I'll show at the end. It's isentropy.com Brevity. But it takes about half the gas to run an arbitrage in Brevity versus deploying a new smart contract in Solidity and running that. So that's one other advantage. And other features, Brevity supports metaTransactions. So I'm looking to partner with brokerages or people that are consumer-focusing, looking to offer DeFi to consumers. You can have a Brevity interpreter that's where the owner of the interpreter doesn't actually pay the fees for it. So the owner can have only USDC in this thing, has no way to pay mainnet fees, and with these EIP meta transactions, you can pay for the transactions of another. And the meta transactions also allow Brevity to run across bridges. So you can send a Brevity transaction across a bridge, and then Bing, it just runs on the other side as that person, as the owner. Another part that's kind of cool is the metering. So the fact that it has a hook when it has calls allows you to meter inflow and outflow of your Brevity interpreter. So if you're a brokerage offering these services to consumers, you can actually charge a fee or something and take a piece, because Brevity has the option to meter and check when things are going in and out of it using this hook feature. And I will now go to a live demo, and we'll actually start playing with Brevity. So if you want to play along, you can go to isentropy.com/brevitydemo. We can talk after if anyone wants a more in-depth demo. But I'm going to go to my webpage and show you some actual Brevity interpreters, and we'll do some Brevity running. So here's a flash loan. We're going to take out a $1 flash loan. And then we're going to announce, Brevity has this possibility to emit key values. So you can basically launch any event in Brevity. You can trigger any event so that your output is indexed. But it has a convenience method called emit key value. So this method, we'll press compile, and hopefully, so we get a gas estimate. That's good. It wouldn't show you the gas estimate on the GUI if you don't own it. So if you go to my Brevity interpreter, you can't control it because I'm the owner. But if you go to Brevity demo without the other parts, without /b, you can create your own. You can just deploy your own on any chain. So I'll press compile, and then I'll run the script. And we'll confirm. And we should get a $1 flash loan so it's going to take out a $1 flash loan, then it's going to trigger some event that says, hey, I have the flash loan. It's going to emit a key value pair where the value is the balance that we had. And then it will return the flash loan. So that succeeded. So Uniswap permitted us to do that. And if we view the transaction, we should see a $1 flash loan in there. How do I get the? Let me go to Etherscan and get this. So cool. We actually see $1 is transferred. You can, by the way, turn this to $1 million if you want. It'll work. I just didn't want to get flagged for some weird behavior, but it's just a number in the machine, right? Another Brevity thing that I'll show you is we're going to make a Uniswap liquidity precision. So this is a Brevity interpreter that already has some ETH in it. So you see that it has some native tokens over here. And what I'm going to do is this script is going to take 10% of my ETH. So the from amount is my balance of ETH divided by 10. Then it's going to wrap it in WETH. It's going to take half that WETH and swap it for USDC. And then it's going to do all the approvals. It's going to do the approvals for the wrapped ETH and USDC and mint the Uniswap liquidity position. Now, if you think about this is 5 clicks. A layperson would have a hard time using this. You'd have to click several times, and this is all done atomically, and it reverts if conditions are not met. So at the end of the transaction, I'm going to, when you make this Uniswap 3 liquidity position, it's going to mint a token, and I'm going to check that I'm, in fact, the token owner. So let's compile, and we'll run this script. Why don't they just put you to Etherscan? That's weird. So here we go. And it did everything that I said it was going to do. It wrapped some ETH for WETH, it swapped the ETH, it made a Uniswap liquidity position, and all this can be obscured, obviously, from the end user. The end user can just see some GUI, and it can be composed like that. So yeah, these are the demos that I had planned for the transactions with Brevity, and I can get into a little bit of the language. I'm also going to show you some example Brevity scripts that AI wrote, which I found pretty impressive. So here's an AI-generated Brevity script. Claude Code wrote that, and it works. So you can read what it's doing, and Claude Code will look for arbitrage opportunities, and then you just press run, and if it runs, then maybe you made money. You can also have it revert if it doesn't make money. So that means that if it did actually run, then you necessarily made money. And just to go over the syntax, I'll go over the README in a minute. Brevity is fairly familiar to anyone who's programmed. There are these preprocessor directives. There are these constants up here. Those are not actually seen. I mean, the names of which are just substituted in, basically. It's like variable substitution. Function selectors, the way you call functions in Brevity is different than Solidity because I want to make it super compact. So I just define function selectors. You just type in the function selector you want. And so the next time it sees the symbol approve, it knows that approve takes an address and a U256. That's the function signature of approve. And then Brevity has one variable type, the word. It's a 32-byte word. And what I learned is that, so Brevity has a lot of intricacies about the EVM. Under the hood, a lot of it's an EVM assembly. And the way that the EVM actually lays out variables is by words anyway. So you don't really need anything except one variable type, a 32-byte variable type. So when you're actually making these function calls like this under here, everything is just a word, even if it's an address or if it's a smaller data type. Internally, the EVM is actually representing them as words. So there's a call in capital letters, does a call that changes state. Static call does not change state, that's like a view function. And then there's basic ifs and things like that. So if this is less than that, revert. It also has a sense of go to, you can tag lines. And then if this is less than that, go to some marker. So you can do for loops, you can do arbitrary branching. Also has a go to statement, obviously. But I want to keep it as bare bones as possible. That's the essentials of the language, basically. It's arithmetic that you're familiar with, just like C or Solidity, calls, static calls, ifs, and go-tos and things like that. And the source code is available on GitHub. So it's Isentropy/Brevity. The README contains a lot about different features that I haven't gone into, but there are a few other features, for example. So because I'm using one word, there's also a way to work with signed or unsigned arithmetic. You can use these special directives. And then in terms of memory, it's an important point that Brevity never actually modifies storage, so it never has any persistent effects on the contract that it's running, except for the calls that it makes. It only makes persistent effects through calls. It does expose transient storage, but that's kind of a utility for you. And it exposes just a simple mem stack. It also doesn't expose any kind of EVM internal, except for a memory stack. So it's like a function call in C with one stack frame and one stack, And it's telling me to please wrap up. So if anyone's interested, I'm happy to discuss this after. I also am looking to form partnerships with brokerages and consumer-facing projects also. And I think the kind of use cases for Brevity, just quickly, consumers, AI finance, as I said, and Ethereum devs who want to pack the most they can into a callback. And this is my contact information. Please come to me with questions. I'm interested in promoting usage of this thing in any case, but also looking for partnerships, especially with people doing AI finance and consumer-facing DeFi. Thank you.